Worldwide, over 500 million people suffer from a major disability, and in developing nations, the loss of an arm or leg is truly devastating. Over the next few days, teams of teenagers will harness their engineering skills and a mere $80 to change the world in the 2016 National Mesa competition. Welcome to beautiful Ogden, Utah, home of the Wildcats, and the Mathematics, Engineering, and Science event of the year. This year's event pits teams of high school and middle school students from across the nation against one another, and more importantly, against disabilities. Over the last 6 months, each team has developed an Arduino-powered prosthetic limb for under $80. Before getting into the science, let's meet some of the contestants.
Hi, my name is Brandon Martin. I'm in 6th grade.
Hello, my name is Justin Stewart and I'm in 8th grade.
My name is Shelby Hines. I'm in 8th grade. This is my 5th year in Mesa.
Hi, my name is Simone Carter. I'm in the 8th grade.
We're from Mount Tabor Middle School representing Oregon Mesa. I'm Lauren.
I'm Nasra.
I'm Pilar. And I'm Abby.
Guess who's back? 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 Guess who's back?
My name is Allie Wood.
And mine's Pauline.
I'm Kate. And I'm Lindsay. And we're Salt Team 5.
I'm Sung Young. I'm a freshman.
I'm Fiona. I'm a junior.
I'm Nathaniel. I'm a sophomore.
And I'm Tiasha. I'm a junior. We're the Mesa Club at Ingram High School.
And our teacher is Mr. Herring.
We're from the Seattle Mesa Center.
And we're Team
Synergetic Prosthetics.
Hi, we're the Common Mesa team from Salt Lake City, Utah. My name is Yogesh.
My name is Prem.
I'm Aruna.
I'm Kanchan.
Like a little bit. I'll be doing two.
Duct tape. And we're here representing Oregon as the Mount Tabor Middle School High School team.
Hi, we're Jasmine and Karina and Ruakawa, and we represent Northwest Middle School, and we are from Salt Lake City, Utah.
Hi, I'm Hannah Porter.
I'm Will Judas. I'm Gunther Stiles, and we're from Glen Burnie High School.
We're representing Maryland at the 2016 Mesa National Prosthetic Arm Challenge competition.
We are number 1. True.
Sarah. Sylvia.
Kaser.
Nancy.
Mustangs on 3. 1, 2, 3. Mustang!
I'm sitting pretty impatient, but I know you gotta put in them hours. I'ma make it harder.
Supporting technician.
Programming technician.
Lead designer. Programmer, designer, assembler. Notebook editor.
Pride, you never gonna know if you never even try. Do it for your country, do it for your name. Cause there's gonna be a day when you're standing in the Hall of Fame. Yeah.
The events of the next couple days are the most crucial part of a process that started many months ago for these teens. In order to compete, each of the teams had to place first in their state competitions. Before that, most of these students had never done anything like this, so a lot of preparation, planning, building, testing, and rebuilding went into this project. The objective is clear: build a cheap prosthetic arm that can perform a set of tasks. At a bare minimum, the prosthetic arms must have 2 opening and closing fingers that are controlled by Arduino programming. That Arduino technology is brand new to this year's competition and has really given some extra space for creativity at the state level. Amazingly, the cost of these Arduino components, sourced through our partners with SparkFun, is included in the $80 minimum. This step requires some real finesse, both in the hardware and software components, as well as strength under pressure during the live competition. The judges will follow strict criteria to determine the winner, but the scoring for this event is relatively simple. There are 4 scoring components to the competition. Number 1, device efficiency. Points here are awarded for having a lightweight and inexpensive device. 2, technical paper. Students have already prepared a 5 to 15-page report on their device. These papers were turned in about a month ago, but students still don't know how they did. 3, poster presentation. Students will give a professional presentation and answer the judges' questions about their devices. 4, and most exciting of all, the performance trials. This is where judges get to see what the prototype can really do. Contestants will have to perform as many tasks as possible in a set time, using only their prosthetic devices. Seeing the students' prototypes today will be a real thrill, and I absolutely can't wait for tomorrow's live competition.
Okay, I am Dr. Kenneth Peterson. I have 7 E's in my name. How many have 7 E's in their name? My first name is Kenneth, Kenneth. It gives me 2. My middle name is Lee, Lee. That gives me 4. My last name is Peterson, Petersen, and that's 3. That makes a total of 7. How many E's in engineering? 3. That's what we're here for. We're going to do some marvelous stuff. Welcome to the 2016 Mesa USA Prosthetic Arms 2 competition. And we're thankful that we had this introduction to the teams that we've been able to see. And I want to hear from, I'm going to call out your names and just tell me, just give a shout out if you're here, and I'm sure you are. Okay, California. All right, welcome to California. Arizona. All right, welcome to Arizona. Utah. And they're our hosts. That's wonderful. New Mexico. Okay, Pennsylvania. All right. Maryland. Oregon. Illinois, and then Washington. Okay, we've invited Sydney Dixon, who is the interim state superintendent of Utah, to come and give you a welcome. Sydney has been involved in education for the past 35 years, and for the last 8 years, she's been at the State Office of Education, first as the assistant superintendent and now the interim superintendent. So welcome to Sydney, who will welcome you. Thank you.
Good morning. Wow, I feel like I'm so far away from you, but it's such a pleasure to be here with you. I love Mesa, and we have been so fortunate in Utah to have Mesa around for quite a while and to watch amazing things that you do as students. So welcome. You all look so excited to be listening to adults speak this morning versus getting your hands dirty and going out and showing your poster and getting ready for your competition tomorrow. So last week I was in Boston and I went to a technology startup company. And I met a young man named David who, right out of high school, got into this company, and he's taking some classes in college, but he actually is their head programmer as an 18-year-old in this company. And David David is Hispanic, grew up in a neighborhood in inner city Boston, and he got interested in programming and now is one of their chief programmers. And I asked him what he was working on, and he said, I'm working on an app for teachers so that they can find out for students who are in elementary school or junior high when they are just starting to disconnect from school a little bit. I want to catch up before they get there so that their teachers know that they need to stay engaged and in school, and I want the teachers to have some interventions to help students. I thought, how impressive that an 18-year-old young man is thinking in that way. And he got interested in science and computers at a very young age and is now looking at computer engineering. His colleague that worked with him was a young woman from India, and she had come to Boston to go to MIT. She'd graduated from MIT in computer engineering, and I asked her what she was working on, and she said in her, she showed me some projects, but she said in her spare time, she's been teaching girls in a homeless shelter in Boston how to code. And these young women go out and try to earn money at night so that their families have food. So she found businesses that would pay these young women a stipend to, so that they would come to the homeless shelter and learn how to code, and then they got a bonus if they finished their project. So what I was so impressed with these two young people, not that they were smart like you all are, because you're here because you're smart and you know how to do hard things, but they thought about how to use that energy and the things that they were really learning and capable of to make a difference in the world. So as you think about the work that you've done with this prosthetic arm, I have no doubt that you'll all go on to be very successful and great people, because you're already doing amazing things. But I hope you'll also walk away from this competition. It'd be great if you get a trophy or whatever you get. But I hope you'll also walk away thinking about, what have you learned? What have you learned about yourself, about how you work as a member of a team? Because not only is it important to learn how to create through engineering, but it's also important to learn about problem solving, creative thinking, working together. And those are things that you learn through the Mesa program. So I encourage you to take those skills and think about your life beyond Mesa and what you've learned from Mesa and from this competition, and make a difference in the world. I'm excited for you, and I can't wait to see what comes out of the competition. And we're so pleased to host you in Utah. You can see it's a beautiful state, and we have great young people here in Utah. And I wish you the best today and always with your future. Thank you.
Thank you, Dr. Dixon. That was wonderful. Okay, I've got just some housekeeping to cover for just a minute, and then we'll introduce another speaker. To begin with, lunch that's on the schedule for downstairs is rotating, and it's open for an hour and a half, so that what the other things you can slip in and take care of it as you need to, because we're going to have quite a lot of things going on. We're very busy this morning. Secondly, you were issued a key for your dorm rooms. They are very serious that you don't lose it, because there is a $150 fee to replace that key should you lose it, so don't lose it. Number 3, after your oral presentations this afternoon, your teams will get a picture. So you'll go through and there's a schedule as to how you do it, but when you come out right after that, then we're going to take a picture of you and of your team. Number 4 is that there's also a student survey to be done with some computers. The room is in 321, and so each of the students need to go in and take that survey. And, and then after the practice sessions, which are scheduled this afternoon, then that's when your prosthetics arms will then be sequestered. So with that, that's the housekeeping things. Now we're very excited to have Stacy Pierce. She's the director of Rockwell Engineering Programs. She's a woman scientist that's done lots with flight simulation. Rockwell is very, very famous with that. And she has a composite degree in computer science, math, and statistics from Rockwell Collins. And then she works for Rockwell Collins. She got an executive MBA that they sponsored for her at the University of Tennessee, which she graduated in 2010. Now, the latest thing that she's been involved in is that she works with the American Indian Services for a program called PrEP, Freshman Engineering Program. And so it's a 7-week academically challenging STEM-based summer school for 7th and 8th graders. And there are 2 American prep programs, one in targeting the Navajo Indians in Roosevelt, Utah, and one targeting Unitas. So let's give a big hand for Stacy Pierce. Feel free.
Seems like this one's not working, so I'll just use this one. I'm kind of a wanderer, so I prefer a mobile mic. But we're going to make use of this. They've asked me to speak for 15 minutes, so not too long, and I am so happy to be here. Couple of corrections, if that's okay. My degree is from Utah State University, and it's the program in Blanding that is targeted at the Navajo Native Americans, and the program in Roosevelt is targeted at the Ute population. So, but anyway, that's not here nor there. I am thrilled to be here today. All of you have come great distances to be here, to spend this time and to make a difference in the world. That's what I believe each and every one of you is going to do. I'm going to share a little bit of background on myself. I'm going to share a little bit of background on flight simulation, which has been an amazing 30-year career for me. A little bit of background on American Indian Services and the prep programs that I'm now running. This is cutting out, isn't it? That work? And then I'm going to give you a challenge. All right, let's go ahead and move on. Oh, I can do it. I am independent. Perfect. This is my family tree. Isn't it beautiful? All right. I'm going to tell you a little bit about my family and my background. My grandfather was, believe it or not, a self-taught civil engineer. He built most of the bridges and dams in the state of Montana. His hobby was gold mining, so he built his own gold mill. So that's the engineering component of my genetics. That's where I get the engineering side of myself. My grandfather was the headmaster at a school in a pueblo in New Mexico called Zuni. That's where my father grew up. That's where my father is buried. He went to high school at Wasatch Academy, which is a boarding school here in Utah, because at that time in the 1940s, there weren't a lot of high schools on the reservations throughout the U.S. So that's how we got to Utah. But as he got older, he wanted to return to Native American education, and we moved to the Four Corners area, to Blanding. Anybody in the room, those of you from Utah or anywhere else, know where Blanding, Utah is? Oh, I got one hand. Well, it's in the middle of nowhere. Let me tell you. It's got no stoplights. There's one in the middle of town, and it just blinks. And if you can imagine, there's no McDonald's. It's a very small town. It's a beautiful small town. My mother was the librarian at the high school, and my father was the principal in Bluff, Utah, and then in Mexican Hat, and then the assistant superintendent of schools. And he spent his life redoing the curriculum to be non-competitive so that the Navajo... Let's try the Wanderer one. Got it? Got it. This is great. And then I can wander. I feel more comfortable wandering. So he spent his life basically, at that point, there wasn't a student from Bluff, Utah that had ever graduated from high school. And that's based upon a lot of different factors. But he basically had his teachers at Bluff Elementary redo the curriculum to be less competitive and more cooperative. And it made a big difference, and that's no longer the case. There are many students graduating and going on to do amazing things from Bluff, Utah. All right. So when I was your age, how many in the audience are 16? Yeah, a lot of you. I was honored, just like you being here today. You're taking the opportunity to be here today. I was honored to go to Utah State University, where I attended Utah Business Week. I met an amazing woman called Susan Mickelson. She was vice president of Evans and Sutherland. And after that week, she invited me, believe it or not, to stay in Salt Lake City with her and go visit Evans and Sutherland. Now, Salt Lake City has a lot of stoplights, unlike Blanding. So it was pretty scary. But I spent that weekend with her, and the next day I went into Evans and Sutherland and met Dr. Dave Evans. Now, Dr. Dave Evans, go back, my friends. If you can believe it, there was a time when we had no computer graphics. Is that hard to believe? And it was in my lifetime. So in my lifetime, computers just crunched numbers. That's what they did, and they did it well, and we were all amazed. He was the first man, he and Ivan Sutherland, to ever draw a line on a computer. They are honored in the Smithsonian as the fathers of computer graphics. And they are from Salt Lake City, Utah, if that isn't cool. So no Toy Story, no video games without this man. And when I was your age, I met this man. What question did I ask this man? What do I get my degree in? How do I work for you? Right? So I got my degree in math, computer science, and statistics, and I went to work for Dave Evans until he passed away, and I had a wonderful 30-year career in flight simulation. How many out there know what flight simulators are? They're like video games on steroids, right? Basically, it's the same concepts as your video games, except for they're put into large domes bigger than this room, where the actual cockpit slides into the dome, and the Joint Strike Fighter, the F-35 pilots, can look every direction and see the synthetic world. And then, not only do we have to do the out the window, we have to do the sensors. So we have to know physics to master those sensors of infrared, radar, night vision goggles. So that's what I did for 30 years, and I loved it, absolutely loved it. Biggest contracts today, F-35, B-52, the Apache helicopter, the presidential helo, that's pretty cool. And then we train 80% of the commercial pilots throughout the United States that keep you safe. But what did I really love about this job? I had a team of 150 engineers, all of the engineers in Salt Lake, all of the engineers in Orlando, the UK, and India, that worked with me building these flight simulators. Amazing engineers. The thing that really got me was that I really believe that simulation saves lives. How many in the audience heard about the pilot that, due to a bird strike, which is birds getting sucked into the engines, had to land in the Hudson River? A lot of you, not the younger in the crowd, but a lot of you heard about that. He landed a plane without engines in the Hudson River. How many people died? Anybody in the audience? 0. Absolutely 0 people died. It was amazing. And what did he say afterwards? I kept my cool. I'd practiced it in a simulator. Every couple of years, a plane has to land without landing gear. That's something they routinely train in a flight simulator. And when our brave soldiers deploy, they practice those missions ahead of time in a flight simulator. So that gave me a tremendous amount of satisfaction in my career. That's what made me passionate. That's what made me work hard. That's what made me want to create the best technology in the world for this application. So I spent pretty much the last 30 years in the domain of my grandfather in Montana, the engineering domain. My father passed away 2 years ago, and I decided I have had an incredible career. It's time for me to pay it forward. So 3 months ago, I joined American Indian Services, and I found the PREP program. It stands for Pre-Freshman Engineering Program. Targets 6th graders, 7th graders, and 8th graders. Get it? Pre-Freshman Engineering Program. They give up 7 weeks of their summer for 3 years. Can you imagine the year after 6th grade, 7th grade, and 8th grade giving up half your summer to study problem solving, logic, pre-engineering, physics, probability, statistics, technical writing. These kids are amazing, absolutely amazing. Key components are daily career speakers, so they kind of don't waste time in college and get a direction. Do I like medicine? Do I like natural sciences? Do I like high tech? So they get a sense of all of those. Motivational, builds excitement, 3 hours of class, 2 hours of tutoring, and then field trip Fridays, which are a blast. So that's what I'm currently doing. Just drove home from Roosevelt yesterday and driving down to Blanding as soon as I'm done here, and I love it. So one of our career speakers is a Native American she's Navajo. She's from Arizona. Her name is Nikki Tooley. She's also a teacher for us down in Blanding, and she has a master's degree in hydroscience. And she talked about X's, okay? They're X's that people put on us, or potentially we put on ourselves. And she talked about her X's being, number one, she's from rural. She's not from a big city. Number two, she's Navajo. And number three, she's a woman. But she has a master's degree in hydroscience. She has traveled to 14 countries studying water and researching water. She was invited to the Capitol to meet the president. And by the way, on the elevator up to meet him, she was with some other scientists. They thought she was a maid. Terrible, terrible. But she got through that X. She turned to only 45 degrees. 45 degrees is almost nothing. She turned it into an advantage, right? So what X's did I have on myself? Because we all have them, right? So I was from Blanding, Utah, a town with no stoplights, okay? I was from Blanding, Utah. I'm a woman. I wasn't of the predominant faith, right? There's just X's that either are put on us or we put on ourselves. And I was smart. And I got to tell you, in Blanding, it's not a good thing to be smart. It's not the thing that makes you the most popular kid in the school, trust me. But I loved it, and I loved math. Absolutely loved math. So how did I turn those into pluses? Remember, here's an X. Is it like 300 degrees, you know? No, it's 45 degrees to turn that into a positive. Being from Blanding, my freshman year, I tried out for basketball, volleyball, tennis, gymnastics, cheerleading. Well, there are only 106 kids in my class. I made them all. It's not like being from Salt Lake where my kids competed in baseball against 150 kids for the baseball team, right? And then basically all they could do is one or two things because they had to be so good, right? So the next year, drill team, I became the drill team captain. That's leadership, lots of volunteer activities. I took state in gymnastics. I took state in tennis because, again, it's 2A. Come on now. How good do you have to be? And I was valedictorian of my high school, not because I was the smartest, because I was really the only one who really cared. So valedictorian, and what did that result in? 21 scholarships. I didn't pay anything for college. So I took that X, being from a small town, and I turned it into a plus. Now, is that as impressive as the fact that my son in a 5A school was able to take the state championship in baseball? Probably not. He had to work a lot harder. He had to be a lot better. But it's turning whatever comes into our life into a positive. Now I'm a woman engineering manager in a company of 30,000. And the president of the company decides to pick 7 women, 3 of which got sent with me to University of Tennessee to get our executive MBA. So 7 women with vice presidential capability is what he was selecting. So my X of being a woman, 45 degrees, it's nothing, turned into a positive for me. So take those perceived X's that you have, whatever they may be, and just tilt it ever so slightly, taking advantage of it. If you're from a city, take advantage of those amazing opportunities of competing and being the best in something. And not only just win state, but go on to college and play that sport. If you win the Mesa competition, that's resume material. Build those resumes and change your life and be all you can be, regardless of your perceived X's, and change those into pluses. Last slide. Let me go back because I love this transition. So the pluses of my life have all resulted in me being able to pursue my passion now, which is education, math, engineering, science, achievement, and bringing that to the reservations throughout the United States of America, starting with Roosevelt and Blanding, and next will probably be Gallup, New Mexico, which is very close to my father's pueblo in Zuni. So we turn those pluses I have into the American Indian Services symbol, which is a beautiful artistic rendition with the graduation cap in the middle, and this is our prep logo with science and math surrounding it. So I challenge you to work harder. Again, I wasn't the smartest person in my class. I was maybe in the top 10 or 25%, maybe, but I was valedictorian because I worked harder. And I challenge myself and I challenge you every day to be smarter. Be smarter than you were yesterday. And then pay it forward. Be generous. If somebody helps you with your homework, help somebody else with theirs. If a teacher means something really has been important in your life, or a coach has been important to your life, write them a thank you letter. That's worth more than $20,000, I promise you that. So pay it forward. Be generous. And then take and make opportunities for yourself. As you're here, if some adult resonates with you, have them mentor you. Build that relationship. Keep those relationships. Look for mentors. You're here today because you're taking this opportunity. What a cool opportunity to be here today and to compete. I'm so proud of you. So take those opportunities, make those opportunities for the rest of your life. And all of you out there, you're going to change this world. You really are. There are so many things you can do with that technology, that part of you that loves technology. There are problems that we need to solve. And I believe the people in this audience that gave up their time today to come and compete, you're going to be the ones that solve those problems for the next generation. So thank you for being here. Thank you for letting me talk to you. And have an amazing next 3 days. All right, thanks.
Wow, that was wonderful. Thanks you so much. Now we're going to have the opportunity to hear from Mr. Vivian C. Suarez IV. He is a senior systems engineer for Northrop Grumman, and he said, he got a degree, Bachelor of Science in Aerospace Engineering from California State Polytech University in Pomona. He's also has a master's from California State University San Bernardino, a minor working with mathematics. He has worked at Northrop Grumman, something like, 29 plus years before it was TRW. And to listen to the kinds of things that he's worked with, Peacekeeper, Minuteman III, small missiles, rocket system launch program, national missile defense, space launch systems, kinetic energy inspector, ground-based mid-course defense, and then something called GBSD. So let's give a big hand to Mr. Suarez.
Thank you. Welcome, everybody. I, too, like to wander. The only thing is I rested my water bottle on me, so I'll hide there till it dries. Anyway, let's go ahead. I guess it's on this chart. What I'm here to talk about mostly is, the excitement and the wonderful world of being an engineer and why I became an engineer and things like that. So why I became an engineer. Originally, I wanted to be a doctor, still in the sciences, and I'll go into that more deeply. Why we need engineers, present and future, and the rewards of being an engineer. So, of course, as Stacy mentioned, we have a love for math. I think everybody here, who loves math? Okay, well, most of you do. I assume all of you love science in some way, right? Science? Yeah, go science, go all of these. Okay, so I love math, I love science, I really enjoy digging into things. One thing you're gonna know is, how do you know you're an engineer? Well, you know you're an engineer if you find that you like to take apart things. How many of you have taken apart things from your parents' radio, fan, something that they came home and it wasn't working anymore? Yeah, lots of you. I got in trouble for doing a lot of that. Okay, you also want to make it better. You want to see how it works. What can I do to make it better? Okay, and also math problems, word problems. In engineering world, you will get a lot of word problems. Now, they may not be the same thing, like if, 4 apples, 2 bananas, the apples cost 35 cents, the bananas cost 55 cents, and you have $6. How many can you buy of each or whatever? Nothing like that. It will graduate to something bigger, like, hey, our stage 2 in our rocket didn't function as it should have. We can't get the rocket back, but can you figure out why it acted the way it did? And through data that we get from telemetry, from radars, we have to piecemeal it together like detectives and figure it out. And then people always bring you things when they break and say, hey, can you fix this for me? So engineers passed thousands of years ago. It took engineers to make this pyramid, or these pyramids. So engineering's existed in the past. They didn't have a degree necessarily, but they did have the knowledge and the ability to design and build things. Columbus came to the Americas on ships that were engineered. They didn't all of a sudden appear. They had to make boats that were smaller, make bigger boats to ships, finally to something that they felt they could cross the ocean with. So that was engineered. Trains. Look at the upper left corner. That's one of the early trains. If we had stopped trying to make things better, we would have never ended up with what's down in the right corner, which, you go from a few miles per hour to hundreds of miles per hour. Cars. Could you imagine if we stopped at the first one in the upper left? It'd take us a long time to get to Salt Lake or anywhere. Airplanes. Now that's a feat in itself. Just think about that. We are able to fly in the air. We can go long distances across oceans, around the world. We can do many things now that we could not do just 100 years ago. Has anybody been to an airport and saw this huge Aerobus, the 380? It's a huge airplane. I mean, the one behind it is a huge airplane, and that's considered small to that one. This plane weighs 1.2 million pounds. So you figure, how do you get 1.2 million pounds up in the air? That's a feat in itself. So, and I'm sure some of you are studying this kind of stuff. I graduated as an aerospace engineer. I wanted to go into building jets, and I ended up going into building rockets. I love it. I enjoy doing it. I've been doing it for almost 30 years now. And hopefully we'll do it for another at least 10 more. But, you know, the feat of taking a plane up into the air is amazing to me, even after I know how it works. Bridges. When you cross a bridge the next time, and I think Stacy mentioned that her dad or her grandpa worked on bridges. Think about the marvel that it takes to span a water span between mountains or whatever it is in order to get across. It's easy. We get in our car and we drive across it. But think about what it takes. It's brains like yours that go into making these bridges the way they are. Boats, as we talked about, you know, that aircraft carrier in the upper top is, I think, about 140 million pounds. It's got to float. Has anybody taken a piece of steel and dropped it in the water? What does it do? Does it float? No. But you got to take something that weighs about 140 million pounds and have it float. So it all goes into water displacement, buoyancy. You got to displace more water than that weighs. Medical, and I understand you guys are working on some kind of artificial limb. You know, amazing where we've gone in medicine. The things that have occurred, the things that allow us to live longer, all because of engineers like you. Computers. You guys probably are more familiar with the ones in the bottom right than you are with the ones in the upper left. But the one that's in 1984, I still have that computer. I also have the one on the bottom right, but I still have that computer. It got me through college, and it was a wonderful computer. But look how far we've gone. You know, and you know we have iPads, and on top of that, who knows what we're going to have in the future. It's amazing how much power we have in a little tablet these days compared to what we had back years ago. I think some of the older people here, like myself, will understand the phone system. I've been places where they still have a lot of these phones in it. Up until the year 2000 or 1995, I was using a phone similar to that red one, a rotary phone. That's because the Air Force base that we were on still had them, and so we had to use them. Anybody know how a rotary phone works? Yeah, probably not. I remember driving in my car with my nephew one day. We had an old van, and he's now married, but he was about 8 years old, and we pulled up next to his dad, and I said, roll down your window, and he's looking for a button to push. And I said, no, you got to take the crank and crank it. He didn't know what that was. So, technology. Okay, so missile programs. These are the types of things I worked on, except the earlier ones, like Atlas and Titan, I didn't get there in time, but the ones like Minuteman and Peacekeeper are the ones I've worked on. Peacekeeper has been decommissioned. Minuteman 3 is the one that's left that defends our country right now. And some might ask, okay, well, you know, you deal in rockets that are destructive and blow up countries and worlds and things like that. Well, I do, but I do it because I don't want to ever use them. I do it because other countries have them. I do it so that we can deter other countries from ever using a nuclear weapon or nuclear power against us. Because when they know we have that, they will think twice, maybe a lot harder than twice, on whether or not they'll use them. So we have to ensure to our customer, which is the Air Force, that these things will operate 24 hours a day, 7 days a week, 365 days a year, that they will always be functional. So do I ever want to see one used? No. If I had a magic wand and could get rid of all nuclear weapons, I would do that. But since we don't have that kind of power, we have to defend our nation. And so I don't ever want to see one used, but I do definitely want to make sure that what we do have works if we ever needed to. That led us into the space program, where we have different types of boosters that launch us into space. I've worked on a couple of those that take satellites into orbit. Some of these have taken man into space and onto the moon. Great accomplishments that we have done through science. You know, who would have, no one would have thought it 100 years ago that we'd ever get to the moon, but we did. And we've gone through space travel. If not for space travel, we wouldn't be able to use cell phones that have satellite access, that we wouldn't have the channels on TV. We wouldn't be able to communicate around the world the way we do with satellites that are launched by these rockets. Now, interesting thing is there's a lot of benefits that come from the kind of work that I do in the sense of things that are developed, such as integrated circuits came from the Apollo missions. You know, the gentleman that developed that for the Atlas, or for the Apollo missions, also it went into other things that we use today in regular life. Then we had more affordable space travel. Because of all the testing we did, all the building we did, it became more affordable to launch things into space. Solid rockets came from the ICBM programs. Storable, solid propellant that is safer to move, transport, house, things like that. That went into our programs now that allow us to take satellites into space. How many know about WD-40? Everybody have a can of that at home? WD, water displacement, number 40. Okay, that means there were 39 other ones. What they used that for was for the Atlas missile. They wanted to keep it from corroding. They were finding that it was corroding, so they sprayed it with this formula that ended up being WD-40 to keep it from corroding. And guess what? They found out it was a great lubricant for other things. So WD-40 came from the missile program. Other things such as laptops. Laptops were used in the space shuttle early on. They built them to make it more feasible to move around. You know, so laptops came from shuttle missions. We have the, she mentioned flight, or the 3D graphics and things like that go into flight simulators. They did that for the space programs. We also have things like the cordless drill. Now, they can't wire something up in space and plug it into inside the shuttle and come out and start screwing in things. So they had to develop something that was portable, that they could take outside and be able to drill or screw in things with a power drill. That came from space. Lots and lots of things came from inventions that were done for other things. So, what are the rewards of being an engineer? Well, there's job satisfaction. You enjoy what you do. You have to enjoy what you do. The work is always challenging. You can't sit around and just say, you know, give me my next task. Be independent. Be inventive on your own. Find ways to make what you're doing better. We fly simulation tools for simulating the missile in flight as far as where it goes. The tool that we have is written in Fortran. Most of you probably don't know Fortran, but we still know Fortran, and we still run it in Fortran. And I love Fortran. But there are other languages, and there are people that are working with us that are trying to put it in a different language. But there's that. So find ways to make things better. Make a difference in society and in the world. You know, find something that you like doing and do it well. For example, in our program, there are people that work on the motor, there are people that work on the guidance system, there are people that work on the entire system. I work on the entire system when everybody gives me their piece parts. But everybody's job is as important as anybody else's job, because if they fail, the whole system fails. So everybody has to do a great job in what they're doing. So whatever your area of expertise is, do the best job you can. And engineering is good pay. You know, if you get a good education, you get a good job, you're going to find that the pay is very, very pleasing. Now, I mentioned that I wanted to be a doctor first. Well, I had a physics teacher that when I took physics in my junior year, in my senior year, I TA'd for him. And he said, are you sure you want to be a doctor? I said, well, yeah, I want to be a doctor. And he kind of talked over with me because he thought I was geared more for engineering. So I still went on in my first 2 years of college as wanting to be a doctor. And it wasn't that I didn't get good grades in either in my chemistry, my biology. It's just that I learned that I really enjoyed doing the physics side of things. And so at that point, I decided, you know what, I'm going to switch to engineering. And I did. So don't be scared. You know, whatever your goal is, go after it. But if you decide at one point that, hey, I like this specialty better, go after that specialty. But make sure that's what you want to do. There are all types of engineers, and I'm not going to go through them, and there's many more than what I have listed here. But there are vast number of things you can do in the science, math, and engineering world. Just find what you enjoy doing the most. Study hard. I think that's been echoed before. Have a good work ethic. Learn to communicate. Talk. You guys are going to be working in groups and teams. Learn to be a team player. Learn to work with others as well as individually. In my career so far, in the 30, almost 30 years now, I have probably 90% of the time I've worked with others, and 10% of the time I've been independent. Because with a team, you can do a whole lot more than you can as an individual. And don't be afraid to be wrong. I think I've learned the most in school because I messed up on a problem or messed up on an assignment, and I had to go back in and figure out why I messed up. So if you're wrong, learn from it. Don't beat yourself up about it. Just learn from it. And learn to think outside the box. What can I do different than what is being done to make it better? And lastly, have fun. I enjoy my work. Yes, sometimes it can be boring. Sometimes I'm reading documents. I hate reading documents. But I enjoy what I do. And I think I grow from there. And I think that's my last chart. So thank you very much. I hope all of you have feel the desire to be in the engineering world like I did. It's a fun place to be. And you associate with very good and smart people that just help build you up and build each other up. Thank you very much.
Thank you. That was wonderful. Now we're going to invite Charlene Liu and Paul Ross up. Charlene is from the Granite School District offices, and she has been over diversity for a number of years. So she has a special award to give. So we'll give a big hand to Ms. Liu.
Good morning. Oh my goodness, good morning. All right, that sounds really good. I'm going to just come closer to all of you. It's a beautiful sight this morning, and I'm so excited to see all of you and to hear that we have Arizona in the house, and California, Washington, Oregon. Was it Philadelphia? Oh, who else am I missing? Maryland, right? No? Yeah. And then New Mexico and Utah. Where's Utah? Oh, come on, Utah. Anyway, once again, thank you for the opportunity to be here. I am so excited this morning that I have a great opportunity on behalf of the Mesa Step Advisory Council here in the state of Utah to really honor one of our stalwarts of Mesa here in the state of Utah, and that is Dr. Paul Ross. So as he's walking up here, I'm going to just share a little bit with you. If we had to call him anything or give him a nickname about Mesa, I guess we could call him the father of Mesa, because he was on the very first committee, very first team of folks who started Mesa about 30 plus years ago in the state of Utah. And he's still here. Yay. So let me tell you, I'd like to share with you, is it okay if I share with you just a few things about Paul you'll never see on a resume or anything else? But he loves kids. He totally loves kids. He may not seem like, I call him a big teddy bear kind of a person, but he seems really gruff. He's been in the military. He actually retired from the military as well. So he says quirky things like, latrines are down to the left, over and out, Roger, those kinds of things. But he's also a Star Wars fan. How many of you like Star Wars? Woohoo, yeah, okay. Your cell phone is what? It has a special ring and everything. His house, he has a dedicated room. They call it a quote-unquote man cave. I don't know how to have a man cave in your house. But he has Star Wars rugs, and he's a University of Utah fan and everything. But most importantly, we love him for his dedication and service to all kids, and especially at this time for Mesa. And I'm just a sap. I always cry. I've worked with him for almost 16 plus years. It's going to be hard. He's retiring. but retiring from Granite School District and actually having to get up and work, but we're going to be bringing him back to help us out in several capacities, especially with Mesa. So please join me in giving a round of applause of great support and thanks to all that Dr. Paul Ross has done on behalf of Mesa. Give me a hug. Oh, thanks. Thank you, thank you.
And thank you. Paul was instrumental. Mesa, as many of you know, started in California. And Paul went there and got exposed to it, brought it back, and Utah has been a great supporter, all that. Now we want to invite up James Dorsey. James is the director of Mesa in the state of Washington and the brand new Mesa USA director. And he has an award to give to Paula Shelton. And so we want to welcome James, who has worked so diligently. Washington was soon after California, was one of the very first states to adopt Mesa, and keep it going.
Thank you. Good morning, everyone. Well, Washington people know this, but I've been with Mesa for 35 years. And I remember a time when I went to Rockwell in school, and I didn't know why I was going there. I had an internship. And it was a room with a space about this big with a drafting table to draft the space shuttle. And I was on a project to work on the drafting and the layout of the space shuttle. And that was in the 70s. And I told them that I don't want to do that because I draft with a pencil and a straight edge. And I spent my entire life, I'm 16 years old, and I spent 15 to 16 drafting with a pencil. And they're like, this is going to be the future. This computer is going to be the future. And it was a giant computer. Nowadays, the computer's like this. All that's to say is when someone tells you that something's new's coming out, something's trending like an iPhone or whatever it is, take a look at it because that's going to be the future. Even if it doesn't work, it's going to work later. And I missed the boat on that one. And so I don't want you to miss the boat. Be creative. Continue to explore. Teachers sometimes don't like this about daydreaming in the classroom. I daydreamed a lot. Don't do it in your math class. So with that, this is my day one as the National Director of Mesa. I'm going to be following the footsteps of some very talented people. And these people have been in this role to make sure you and your friends in school have the opportunity to do creative things with your hands, to learn about how to develop a prosthetic arm that will help folks be able to improve the quality of their lives. And that experience that you have is going to help you in your professional world. I want to bring up a colleague, a mentor of mine, Tony Begay, if he's still in here. Tony, can you please step up if you're in this room? Tony Begay is the New Mexico Mesa director. He has been running National Mesa for some time. He was the first Mesa USA person I could go to and kind of learn about what's going on in the rest of the country, and particularly with our Native American students, that will make sure that they're successful and they have opportunities to be engineers and scientists in this great nation of ours. And we can take those experiences and help the world, help the globe. Tony and I are going to recognize another colleague of ours who was one of the early starters of Mesa USA, and that's Paula Shelton, who's retiring. So Paula, will you please step up? She is the Maryland Mesa director. I'm keeping this in plastic because I know how you like to keep things neat. Stay up here, Paula. I'm going to say a couple of words. Paula has, she doesn't like to brag about this a lot, but she's a researcher and she's a scientist and she's creative and she has worked with a lot of STEM programs outside of Mesa. I can go on. You've probably had I'm not going to guess, but a 30-plus career in science, technology, engineering, and math. And we're going to greatly miss you. We hope that you volunteer with us, your direction and your voice. in terms of where we're going to go to serve our students has been very powerful, and you've been a great mentor and a great inspiration. I'd like you to say a couple of words to the students, if you don't mind.
Okay, another surprise. I usually like to stay behind the scenes. I have been really honored to be the director of the Mesa program at Johns Hopkins University Applied Physics Lab, which is a mouthful. It has exposed me to what is coming in the future with technology, and it has been an honor working with all of the other directors. I think that we share a vision for our students, and that is that you will go out and become the dynamic leaders that you were meant to be. Each one of you has a gift, and our goal and our dream is that you find the gift and you rise to the top with it. So I won't be far. Yes, I will still be involved with the Mesa program. I wholeheartedly believe in it, and I have seen the results of it and how it has impacted the students. So I thank you. I thank you all.
Stay here, stay here. I'd like to also ask all of the other Mesa USA directors to please come up so everyone can see who you are. And we also would like to take a moment to honor Rita Brock. Rita, would you please come up, who's the Utah Mesa director, who has made all of this happen? Rita is the one that's made sure that you're having a fun time, that you're in resident halls, that you guys are eating, you guys are going to have a good time. And we just all want to thank you, Rita, from the bottom of our heart for all the great work that you do on behalf of Mesa. And this woman, you make sure you thank her for all the experience that you're having, how you got here in your shuttles, and how you're going to get home safely, and how much fun you're going to have in this program. And Rita, this is for you, for all your great work. I can take the plastic off of yours. On behalf of Mesa USA,
Thank you so much.
thank you for being such a great host. I don't know where Dr. Jamie Bracey is, but Dr. Jamie Bracey's the Mesa director in Pennsylvania. She'll be hosting Mesa for the next 2 years in Pennsylvania, where we'll be rotating to. But where is Jamie? She's hiding out somewhere. I just saw her. So I want to say thank you very much. This is the leadership for the nation. We're going to be growing Mesa and moving forward. Any kind of ideas and suggestions you have to make Mesa better, these are the folks that you want to talk to help improve the program. Now, you guys get out and have a fun time. I'm going to turn it over to my mentor, Tony, to say farewell from the USA team.
Thank you, James. I want to say thank you to our hosts, Utah. Thank you very much for your hospitality. First of all, to be on your lands, to be in your country, we appreciate it. And Dr. Peterson, it's really good to see you. You've been with Mesa, I know that for sure, for a long time. And for you kids out there, I want to mention one word, and that word is history. We have a history. Mesa has a history. We're over 30 years old, almost 40. We're going to be reaching 40 pretty soon. We have that history. And no other program I can think of has that in STEM. So you're part of a very, very unique organization. And we do this all for you. We don't do it for ourselves. We do it for you. Because we believe in you. You're going to take us to the next decade, 2 or 3 decades. We know that. We have faith in you. We'll put all our efforts into you. So someday when you reach our age, you help somebody else. Be a mentor. Join Mesa. Be a director at Mesa or at that capacity. And build up the next generation of Mesa students. And I want to also thank Ms. Dixon. I'm not sure if she's still here or not. I think she's gone, but she's been encouraging. It's encouraging to me to hear her say she likes Mesa, she loves Mesa, because this state, Utah State, is part of Mesa, and we want to keep it that way. We want to keep Mesa strong here in this state because we need Utah, we need Colorado, we need Washington, we need Oregon, California, Arizona, Illinois, Maryland. We need all of them to make us stronger. So keep that in mind, students, while you're competing, because this is all for you. We raise money. We have sleepless nights for you. Just keep that in mind. So someday you can help somebody else again. Thank you again.
Isn't that great? We have people that are committed. Okay, what happens now is that we've had the judging going on next door at the posters. Can't go in there. You have time now to kind of a quiet time to practice your oral presentation or whatever you need to do, and then we have lunch that starts at noon. So thank you very much. We'll see you throughout the day. This is great.